The key difference between the positive displacement type pump and the dynamic centrifugal pumps. Positive displacement pump, as I have explained this before, it squeezes fluid to develop pressure. So fluid comes from this larger hole, get into this gear, it rotates like that, it traps the fluid on these empty spaces and basically squeezes that into a smaller area. So this one I have shown you before. This oil pump, the lobe type, also does the same thing. This vane compressor can be called also a pump if it's handling liquid. They all squeezes the flow and force them into a smaller volume, and therefore because of the restriction it cannot go, the pressure start to build up. So that's why it's called the positive displacement pump. Another reason for that is the flow is always kind of constant. So whatever traps in there, it has to go somewhere. So the amount of flow will be same for the if it's a pump, it's incompressible fluid. If it's an air, the total amount of air is also same. The volume is reduced, however the total mass of the air is fixed. So it is positive displacement. On the other hand, dynamic pump works completely different ways. So it creates vacuum, low pressure inside the housing. So these, as I have explained, the fluid comes from this side, and it is still right. Everything is submerged into water. It is stay or coolant. So right there, these holes are connected with this guy, these holes. So when it rotates, it tries to create vacuum inside behind these impellers. So when it rotates like this, and that creates a little bit lower pressure compared to the outside fluid. So fluid rush into the housing there, and by the rotation of the fluid, that actually develop a lot of centrifugal energy, half mv square, and that energy actually you can see the output side, the volume start to go is up. So here too, the output side volume increases. So that increase of volume actually develop the, when you increase the diameter, if the flow is same, increase um, the volume, it will drops the velocity. So Q is equal to area times velocity, the flow rate. So when it drops the velocity, it drops that half mv square, that kinetic energy of the fluid. However, energy is constant. You can destroy or create. You just convert one form to the other. So then that kinetic centrifugal energy converts into pressure energy. So by increasing the area. So that's the key difference basically. So by this rotation, vacuum or lower pressure is created inside the housing, and then the outside flow, output side, the volume start to increase. So that drops the velocity by adding the pressure energy into the flow.